This is pretty good. So I want to do a quick video on this repository I found because it allows you to make music locally and offline on your machine. And this is by far one of the best offline music generation programs that I have seen or played with. The music this makes is quite good. And on the other side of that coin, you can put in your own lyrics and things like that, which can perhaps be quite funny for those of us with a specific sense of humor. Unfortunately, I won't be able to really show those sorts of songs in this video, but we are basically just going to quickly look at it and then we'll go through the steps to install it. Apparently, it can be run within 8 gigabytes of video RAM. As you can see here, it requires a minimum of 8 gigs of video RAM for the base model. However, I am running this today on my dual 3090 Ti machine, and I will put the specs in the video on the bottom right there. So without wasting more time, let's just take a look at this real quick before we just jump in and install it and play with it. This is called DiffRhythm, or Dion. It is an open source diffusion-based music generation model that is capable of creating full-length songs. And then they talk a little bit about the name and things like that. There is a paper here if you are interested in the kind of tech specs and things like that. However, honestly, for this video, I just want to kind of show the model first and foremost because it is quite good and it's fun to be able to do song generation offline locally without having to pay for subscriptions or be bound by lyric censorship, I suppose one could say. So really, we're going to just go ahead and actually jump in and install this. So we can see right now we will be using the base model as the full is not really out yet. However, the base model will allow us to generate a song 95 seconds in length or 1 minute and 35 seconds, whereas the full one will be apparently 4 minutes and 45 seconds, which is a relatively long song, I suppose. We are now going to just follow the steps to get this locally installed and running on our machine. Fortunately, it is not very difficult. Under the inference section here in the GitHub repository, we can simply begin by cloning this, which we can copy and paste into the terminal right here. And upon completion of that, we are going to navigate into the DiffRhythm directory. They do have a suggestion here to use a Conda environment for this, which I very much like, as I traditionally choose to use Conda environments myself. So we can see that they want you to create one called DiffRhythm using Python 3.10. Now, as I have already been playing with this a little, I already have the DiffRhythm environment. So I'm just going to append one to this so that it doesn't try to conflict with what I already had when I was testing this. And we'll press enter there, and it will ask us if we want to agree to download and install these packages, which we will. And once it's completed, we can just activate the environment by copy pasting this command right here. Our next step is simply going to be to go ahead and actually install the r/requirements.txt, which basically will just go ahead and install the requirements for this actual repository. Now, one thing I did actually neglect to mention is we also need to install something called eSpeak. If you just copy paste this in like this, it will go ahead and install it, assuming you are on Linux. This is something that just kind of helps with, I think, like phonemization or characterization, or just, it helps it with like language and things like that. And eSpeak is actually kind of old historically. It started, I think, in the 90s as a program. I've spoken about this in a different video. So eSpeak is actually kind of cool just to look into because it's kind of historically neat to see something that old still being used. Obviously, it's been iterated upon and things like that, but I digress. So you see I have that already installed here as it's on my system for some other things that I use. But once that is done, the next thing we are going to do is just jump down and now go ahead and install the requirements to run these repository and programs. And that's what that will do right there. And once the requirements are all installed, you can basically just go ahead and actually begin playing with this, which you will just do by running this command right here, which will go ahead and just kind of run it. Now, if you are doing this for the first time, keep in mind that it is going to download the models as well. This is really not a large file download, so it will be happening pretty quickly depending on network speed. Mine is already downloaded onto this machine, so it will instead just actually load them. Oh no, okay, so I did delete all of the previous files. So as we can see right here, it is downloading a 2.2 gigabyte model file, and once it does this and perhaps downloads a couple other relevant things, we will actually be able to go ahead and we won't actually really see anything happening because this is all more command line focused here. However, what will happen when this runs is it will actually go ahead and generate a song based off of a sample reference audio clip that is included in the repository when we clone it, as well as some sample lyrics. And something that is actually kind of neat about this is it really like adheres to lyrics. So while we're waiting for this, if we actually click on this Hugging Face Space demo, which I probably should have mentioned earlier for those who don't want to run this locally but do actually want to be able to play with it, you can click on the Hugging Face repository demo right here, and this will allow you to actually interact with this online through Hugging Face's, I think, 0. But you can see here that it specifies the lyrics along with timestamps for the lyrics, which apparently helps it to generate more consistent and coherent music. It also has some best practices guides right here for audio prompt requirements, generation duration limits, and then it talks about supported languages, which are Chinese and English, which is kind of cool to have it multilingual. There are some advanced settings, and then just as kind of a default thing for the actual reference audio, there are some examples. Now, personally, I don't actually like having to use a reference audio script as well. I would prefer just to be able to give it lyrics and then just describe the style of music that I'd like to have and get it to generate like that. Fortunately, that is actually possible, and I've made some modifications to some of the scripts here so that we can actually just use a text prompt and be able to omit the reference audio file. And I have been doing it with that and playing with it, and that works fine. So we can see that it is going ahead and now downloading another 1.33 gigabyte model. So it will take a little bit of time, but once that's done, we'll actually just be able to see it run for the first time, and we'll move on from there. So once all the downloads complete, it will automatically just run for the first time. And we can see, like I said, there's not a lot of like visual interactivity in terms of the output, but it does just tell us how long it actually took to generate the song, which is 95 seconds worth of song, or about a minute and a half. So it is quite impressive actually how fast this works. Well, the default song is not really of too much interest to me. If we do actually want to know where the heck to look to find it, we will just go into the file browser. We will locate the actual directory that this was cloned to, which is called DiffRhythm right here. And then from in there, you will see that there are a lot of things, so it can be confusing to actually find the generations. But we will just go into infer, example, output, and then output.wav. If we go on properties, we will see that this was modified a few minutes ago, which is when this actually ran right here. And if we click on this and play it, we will hear a generated song that happened locally, offline, and in 6 seconds, which is quite good. So, I mean, like I said, I'm not going to really play the songs too much, one, because it's just like, I don't like playing music at all in any videos. However, this is a default example one, so the fun really comes, in my opinion, when we go ahead and actually play with our own, which is what we're going to do now. So fortunately, one of the issues here in the GitHub repository kind of pointed me in the direction to understand how to actually just get a text prompt instead of needing a reference audio file. And that was just the one right here from a couple of days ago where this individual asked if reference audio was always needed. And fortunately, a collaborator said text prompt is supported as we use Moulons for style embedding and extraction. However, they observed that textual controllability is weaker than that of audio prompts, which I suppose is understandable. However, and someone else here mentioned that they have been using it as well just with text only, and it was working pretty good. So fortunately, all that needed to be done to actually get the text only working here, and I will just put these scripts up somewhere so folks can actually do this themselves and then have more, I suppose, control over it without having a reference audio file. But there are kind of two associated scripts here that we modified. So the first was this infer.py, and actually I should show this one first. So the first is infer_utils.py. And basically all we did is scroll down here and then add a function to get the text style prompt. So basically this allows us to actually use text to generate or dictate the style of the music we would like to have. And then Following that, in the infer section, we added that into the imports here from the infer utils. So basically get text style prompt so that it actually knows that that is now a thing that we can also do. And then basically we added an argument to here so that we can actually define a text style when we go ahead and run the script, which we'll follow up with right after this. So that makes more sense. And we can see here, like, for example, classical piano with hopeful mood. And then following that, there was one other thing here just to make sure that it is actually there. So make sure the style prompt is actually an argument here. And other than that, it really was not much else necessary to actually get it working with text, which was good. The only other thing is in this script that we actually run. So if you recall, if I clear out of there, the way to actually run this per the GitHub kind of like getting started inference section was just to run the bash scripts/infer.sh. So that's what this script is right here. So we can see now that we have a style text flag for this as well. And then from in there, we can go ahead and dictate the kind of style of song we want to have generated, which I have just put here, energetic hip hop with smooth vocals and rhythm. And I just simply omitted the actual reference audio flag from here, and it worked totally fine. So basically all I'm going to do is just swap these files with the ones that are in the cloned repository, and I just have these in a folder called mod scripts. I apologize if this was a little perhaps verbose and tough to follow, but I'll put these scripts up somewhere. So basically, if you're trying to follow along right now, you will just do as I do on the screen and it will work, hopefully, knock on wood. So in the cloned DiffRhythm repository, which we'll just start from 0, I guess here, we'll go in here. And then first we are going to want to replace the infer Python scripts. So we will click on infer right here. And then I am just going to drag this in and it will ask me if I want to replace it, which I will. And I'm going to do that with the updated infer util script as well, which we will do that right here. Now, the only other thing we need to do is just replace this script, which is in the scripts folder right here. And we can simply drag this in and we will replace it. And now, basically, if we were to actually just run this again, it would generate a song in a like kind of cool hip hop style. The other thing that I want to note is how to actually modify the lyrics for this, because that is obviously going to be a big part of being able to have fun with this, I suppose one could say. So if you want to modify the lyrics, you will just go into infer, and then under example, you will see that you actually have some different options here. And one of these would be for the Chinese lyrics, which we can see right here. The other is for the English lyrics. And basically what you would do is just go ahead and actually modify each of these lines to whatever you wanted your lyrics to be. And I probably should finally note that if you want to define which of those it actually uses to pull the lyrics, I think the default one, where we have changed this now, but the default one would have been the CN, so this would have been pointing to the Chinese lyrics, but we just have it here now for EG_EN, which is the English lyrics. So basically, I am now just going to go ahead and run this with the English lyrics that we have set everything to. So basically, when I run this script right here in terminal, it will go ahead and actually generate a song in the new style of the hip hop. And let's take a look at the VRAM utilization while we do this. I do think it stays at like 6 or 6.5, but then right at the end it spikes to like 23. So there was obviously that flag in there, or some instruction to limit it to the 8 GB of video RAM. So actually following this, we will go ahead and just do that real quick, because yeah, we see right there, just like kind of max the card for a second. So we will see how we do that and if it gives us the resulting like within 8 gigs of video RAM. However, we do now have a newly generated song, and let's take a listen. And it will be in the output folder under example, under this kind of directory path here. So one of two things. One, I'm using like a portable monitor here, and the speakers are, as you would expect from a budget portable monitor. Two, it's pretty good, actually. I know, like, I didn't really react to that, but I mean, I'm not like so interested in the music when it doesn't have hilarious lyrics, but this is really quite good. So I will maybe just play a snippet of this in the actual like video as well, not through the speakers, through the microphone to your audio, just to get a feel for how it is kind of instrumentally and things like that. But basically the next thing I want to do here is just make these lyrics quite hilarious, but at the same time in keeping with a channel that is not like NSFW. So all right, so I just changed the first 4 lines here. You know, this just, I don't know. So we're gonna go ahead and now we're gonna run this again, and then we'll see how it goes. And again, I will maybe just overlay me actually playing it from this monitor by just dubbing the actual track in, because this monitor speakers are so, if you will. However, I will also have the lyrics open here when we actually go ahead and run this, just so we can kind of read along with the song. And it is all set now, so we will just go ahead and play it. Computers, give me your body. No, so like, again, it's not even that funny because the songs are actually good that it generates. So this is really high quality. And let's just try one other thing. I don't want to just like drag on and keep like recording myself doing silly crap with this, but this is quite impressive for something that runs locally. I'm not going to clickbait and be like Suno's done, this local solution smokes it. I might clickbait, but probably not. But this really is something that is quite impressive in my opinion, and I'm very happy to have located this. So if we go into the infer.sh right here, I could just go ahead and kind of change the style of the generated song, which we will do, but we'll keep the same lyrics. So we'll try it with classic rock with heavy drums and lead guitar. All right. Let's check it out with a more rock style. So really, like, all right, we'll try one more of like EDM. I'm just going to write EDM and we'll see what it does. I'll do it in all caps. EDM. All right, let's go. And then after this one, I probably said that like 4 times now, but I mean it this time. After this one, we'll go ahead and just take a look at how to actually append that command to limit the VRAM utilization to 8 gigs or so and see if it works, as that will really open up the amount of folks who can run this locally on their machine. So that would be fun, and we'll take a look and see how we can do that. All right. We'll try our EDM one now, and then we'll go and take a look at how to get this working in 8 gigs.
Oh yeah, baby, I want a big feet, GPU.
This is pretty good.
Me so naughty. Computer, please me your body. Static whiz through fake white.
Something I noticed is that I was always so impressed with like Suno and the online stuff is it actually does a decent job of fitting the lyrics into like the actual time of the song. Like not like what's the term for like 4/4 or whatever, the time signature of the song. So this actually does a pretty good job of getting the lyrics to go with the audio within the specific time signature that it dictates it should have. So that is kind of cool about this. And that is another reason why I was so impressed with this, is that it was kind of allowing me to draw parallels to what I was noticing with this, with some of the things I've noticed with Suno or other online like state-of-the-art music generation sort of program. So really all we're going to do now is just take a look at the actual flag or instruction that they had mentioned to actually limit this into 8 gigabytes of RAM, as I'm pretty sure a lot of folks will be interested and want to know how to do that. Okay, so to get this working in 8 gigabytes of video RAM, we do need to modify one of the scripts in here. Fortunately, it really will be quite easy, so we'll just kind of do that real quick. All we need to do is open the info-utils.py, which we can go to by just going to the DiffRhythm cloned directory, then opening infer, and then opening the info-utils.py, which is the Python script. And then all we need to do is right here in line 29 for decode audio, we just need to change chunked from false to true. And then apparently with this, we should see our video RAM drop significantly. So we have, just make sure we save this, which we did. And then we'll just go ahead and run it once more. And then we'll just keep an eye on the video RAM utilization throughout the entire process of this to see if we have that high VRAM spike at the end of the generation or not. And if not, then I suppose we're good to see this within 8 gigs of video RAM. Okay, so that didn't seem to work, and I'm not quite sure why, because it jumped to like 23 at the end. Unless it just takes up as much as it has available to it, which I suppose may be a possibility. So I would say if you have like a 12 gig or a 10 gig card, just try setting that to true in the decode audio function, which was just in that script we edited right here in info-utils.py. Really, that is going to conclude our look at DiffRhythm, which in my opinion is a fantastic offline and locally hostable, runnable music generation AI, which is a lot of fun. And again, you know, it is Friday night. If you have, you know, like plans with friends or something, and you are like kind of like a nerdy group of friends, you can download this and then change some of the lyrics to perhaps be quite funny, and you will likely have a rather enjoyable Friday night. So with that said, that is probably what I'm going to end up doing for the rest of the night. And I wanted to show this. It is really quite good, and I very much enjoy this. So that's going to wrap it up, and thanks for watching.